Bismillahirrahmanirrahim. Dear students and audience, in this video we will talk about basics of hypothesis, experiment, and error. So let's first see what is a hypothesis. A hypothesis is an assumption, an idea that is proposed for the sake of argument, so that it can be tested to see if it might be true. So this is basically an untested statement, assumption or idea, which is still to be tested whether it is true or not. In Urdu we call it mafruza. So this is a typical example in the field of animal science is the new feed increases milk yield in cattle. Suppose this is our hypothesis and we need to test it. So there are two types of hypothesis. One is null hypothesis and the other one is alternate hypothesis. Null hypothesis assumes no effect or no difference between the two groups or between control and treatment, while alternate hypotheses assume an effect or difference exists. For example, in case of null hypothesis, we can say mean 1 is equal to mean 2, no change in yield, mean of group 1 is equal to mean of group 2, so there is no difference between the two groups. But in case of alternate hypothesis, mean of group 1 is not equal to mean of group 2, so they are different yield changes. So what is its role in testing is default assumption to be tested. First we will test null hypothesis, and alternate hypothesis usually what you want to prove or support. What kind of decision we should expect from null hypothesis? Reject H naught if evidence is strong enough, and accept H naught, HA when H naught is rejected. Similar to the case of hypothesis, we have two types of test, one-sided versus two-sided. They are also called one-tailed versus two-tailed. So one-sided is the test for an effect in one direction only, while for two-sided test for an effect in both directions. For example, in null hypothesis is same in case of one-sided and two-sided, but if you look at alternate hypothesis, they are different. In case of one-sided, we have only one-sided alternate hypothesis. Mean 1 is greater than mean 2, or mean 1 is less than mean 2. So one of these two would be alternate hypothesis in case of one-sided test. While in case of two-sided test, mean 1 would not be equal to mean 2. They can go both sides. So critical range entire significant level alpha lies in one tail. In case of two-sided test, we would have two tails and alpha would be divided into equal parts. So what is usually the purpose of one-sided is to check if a parameter is greater than or less than a specific value. While in case of two-sided, we check if a parameter is different from a specific value. Example, new feed increases milk yield, test only for increase. While in case of two-sided, new feed changes milk yield, test for increase or decrease. So in case of one-sided, there is a risk we may miss effects in opposite direction, while two-sided test is more conservative, harder to reject H naught. And why we use one-sided? When direction of effect is known or meaningful, we already know that this is the direction, but if we are not sure, then we should go for two-sided test when any difference matters regardless of direction. So here I have shown the typical curves for one-sided test and two-sided test. So in case of one-sided, we have alpha 0.1, 10%, and 1 minus alpha is 0.9 or 90%. So this navy blue is rejection or critical region, and sky blue is basically acceptance or confidence region. But in case of two-sided test, we would have alpha divided in two parts. One is alpha is 0.05 in right side and alpha 0.05 on the left side, and confidence range region or acceptance region is same in both cases. So this is give you pretty much of an idea what kind of one-sided or two-sided test mean. So now let's go towards experiment. Experiment is a test or investigation or controlled procedure specially planned or designed to provide evidence for or against a hypothesis. So whatever we will do to prove or disprove a hypothesis is called experiment. It is a test or investigation or controlled procedure specially planned or designed to provide evidence for or against. It can prove our hypothesis or it can disprove our hypothesis. So its purpose is to observe cause and effect relationship between different variables. Example is testing whether a new feed increases milk yield in cattle. And key elements of an experiment are control group, treatment group, randomization, replication. Similarly, when we conduct experiment, we have two types of errors. One is type 1 error and the other one is type 2 error. So type 1 error is false positive, meaning we reject the null hypothesis even though it is actually true. So simplified example is we are testing if a new feed increases milk yield, while in reality the feed has no effect, but mistakenly we conclude it does increase milk yield. So it is called false positive. So we reject the null hypothesis even though it is actually true. In general terms, it's like convicting an innocent person. So person was innocent, but we convicted him. And what is a type 2 error? It is called false negative. We fail to reject null hypothesis even though it is false. So simplified example is, for example, we are testing if a new feed increases milk yield. In reality, the feed does increase milk yield, but mistakenly we concluded it has no effect. So its analogy is letting a guilty person go free. So a person was a criminal, but we freed him. So these two types of errors are there in an experiment: false positive type 1 error and false negative type 2 error. So if we reject null hypothesis despite of being true, it is type 1. If we fail to reject or simply accept null hypothesis even though it is false, so this is type 2 error. So let's give a simple example. Planning the experiment, we will define the research question: does a new feed increase milk yield? We formulate hypothesis. Null hypothesis, no difference in yield. Alternate hypothesis, yield increases with new feed. We will identify variables. Independent variable is type of feed, dependent variable is milk yield, and control variables breed, age, environment. Now we need to design the experiment. We will select control group, we will select treatment group, randomization assignment, randomly assign treatments to groups, decide sample size and duration. And next is execution of the experiment. We need to collect data, we need to maintain controls, and we need to replicate multiple animals per group to reduce random error. Now we need to analyze data. We will calculate mean, standard deviation, and visualize it. Then we will choose a statistical test, t-test or ANOVA, significance level alpha 0.05, compute t-statistics and p-value. If p is less than alpha, reject H0. If probability value is greater than or equal to alpha, fail to reject H0. So then we can report the result according to its nature of the experiment. Thanks for your attention. You may ask question or feedback in the comments.